Right, so today we are going to be covering the second part of our notes, which is reference angles. So associated with every angle drawn in standard position except quadrantal angles, there is another angle called the reference angle. The reference angle is acute, so that part is important. It has to be acute. It's formed by the terminal side of the given angle and the x-axis. Okay, so those are the two important parts. It's going to go off of the x-axis and needs to be an acute angle. So that means it needs to be less than 90 degrees. So if you get something that's more than 90 degrees, you did something wrong. Reference angles may appear in all four quadrants. Angles in quadrant 1 are their own reference angles. And then they give us the examples, but I'm going to go ahead and go over the examples and then we'll use this as a little review first, just so it makes more sense. So we're going to sketch each angle theta in standard position, and then we're going to find the reference angle alpha. So this little A, it looks like a little fish. That's what we use for the reference angle. That's what the reference angle means. And so theta is our original angle, and then alpha is going to be our reference angle. Okay. And it's measured from the terminal side of the original angle to the x-axis, not the y-axis. So make sure that's very important. It is not the y-axis. So when we're doing these problems, all I'm going to label is the x-axis. So here is 0. This is 180. And this is 360 once we come all the way around. I am not going to label the other ones because I do want you to use those numbers. All right, so 135, we know this is going to be 90. So 135 is between 90 and 180. So if you graph 135, that is going to be right here. That's where our terminal side is. This is our initial side. So that is this angle right here. All right, so our reference angle is from the x-axis to the terminal side. So in this case, the negative x-axis is closer to our terminal side, so we need to use a negative x-axis. And so this is our angle here, which is the little a. It looks like a little fish, and it's alpha. So to find how much degrees that little angle in there measures, we know that theta is equal to 135. So from here to here is 135. We know half a circle is 180. And so we're going to take our 180 and we are going to subtract our angle, which is 135. And that gives us 45 degrees. Okay, so that means our reference angle alpha is equal to 45 degrees. And that's it. So let's go ahead and try the next one. So this one is theta equals negative 210 degrees. So that means we're going to have to go in the opposite direction. So this is 0. This is 90. Now remember, I'm not going to write the number down because I don't want us using those numbers. This is 180, and that's actually negative 180. And then this one would be negative 270, and then this one's negative 360. Okay. So 210 lands between 180 and 270, which would be right here. Okay. And so then that means that this angle here starts here. We go in the clockwise direction because this is a negative angle. And that is our theta, which is negative 210. Now your reference angle goes from the x-axis, either the positive or the negative, depending on which one's closer. So the positive x-axis, the negative x-axis to here, our terminal side. So this little piece right here, from here to here is considered to be our reference angle. Okay. So to find that, we are going to take the negative 210 and we are going to subtract the negative 180. Okay, and that's going to tell us how far it is. Now remember, when you subtract a negative, that ends up turning into a positive. So 210 plus 180 gives us negative 30. Now our reference angle cannot be a negative number, so I'm actually going to take that off. And the measure, they just want how many degrees that is. They don't care about the direction. So it does have to be positive. It cannot be that negative number. So you're going to do alpha equals 30 degrees. All right, let's see the next one. So here we have theta is equal to 290 degrees. So we're going to graph that. This is 0. We're going in the positive direction. This would be 90. This would be 180. This is 270. And then 290 is more than 270. Once we come all the way over here, it'll be 360. So it is between 270 and 360, which would be right here. So this is your initial side. This is your terminal side. And it starts, it comes all the way around and stops here. So your reference angle, remember, is the closest distance from the x-axis. So in this case, we're using the positive x-axis and our terminal side. So it's this little section right here. So this number on our x-axis is 360. We subtract our angle. So our angle is 290. So we subtract 290, and that gives us 70 degrees. So that means our reference angle alpha is equal to 70 degrees. And that's it. So let's look at the next one. Here, theta is equal to 80 degrees. So here is our original side. Because it's 80 degrees, it's going to land in the first quadrant. Actually, I should put it a little bit closer to the line. Okay, because up here is 90. And so 80 is an acute angle. It's less than 90 degrees, right? And this is the closest distance from our terminal side to our positive x-axis. So in the first quadrant, if theta is equal to 80, then that means that alpha is also equal to 80. So if your angle lands in the first quadrant, your theta is also equal to your reference angle. Okay? And that's only in the first quadrant. All right, now we have these ones that are in terms of pi. So this first one is 4 pi over 3. So remember, this is 0. This would be pi, and this would be 2 pi. All right, so I'm going to go over how to graph again like I did in the last one. From here to here is 1 pi. And so it is cut into thirds. Right here it gives a 3. So we're going to cut into 3 pieces, right? And we want a total of 4 out of the 3 pieces, okay, from up there. So I'm going to make my other pi, that would be 2 pi's, and I would make the other splitting into 3 equal pieces. So if we want 4 out of the 3, we go around, and this would be 1 piece. I'm going to have to use a different color. From here to here is 1 piece. This is 2 pieces. This is 3 pieces, and this is 4 pieces of the pie. So that is how I graph my, I'm a little too long. That's how you draw your angles in radians. So let me go ahead and erase this that we don't need. There you go. So now that we have that one, our reference angle is going to be this little section right here, right? Which I shouldn't have probably erased too soon. Okay, I'm just leaving it just so you guys can see the pieces of the pie. And so our reference angle is from the x-axis to this little piece right here. So this little section is our reference angle, which is only 1 piece of the pie. Okay, and it's only 1 pi over 3. And that would be your reference angle. And that's it for that one. But realistically, like I did erase these, you don't need all these little lines because that was just to help us graph it by using the little pieces of the pie. All right, the next one. So here theta is equal to negative 5 pi over 6. So it is negative, so we go in the negative direction. So here's 0. This is negative pi. And then once we come all the way around, this is negative 2 pi. We have 5 pi over 6. So from here to here is 1 pi. We cut this into 6 pieces. So 6 equal pieces. So that means this would cut it in half. And then this would be 1, 2, 3. And this is 1, 2, 3. So that's a total of 6 pieces. And we are doing negative 5 pi over 6. So we start here on the initial side. We go in the clockwise direction because it's negative. So that's 1 piece of the pie. This is 2 pieces of the pie. This is 3 pieces of the pie. This is 4 pieces of the pie. And this is 5 pieces of the pie. So this is where we would stop. So there's our initial side and our terminal side. And our reference angle is closest distance from the x-axis, so here to here. So this is only one piece of the pie. So this is only one piece of the pie, and our pie is cut into 6 pieces. So that is going to be our reference angle. 1, 2, 4. And that's it for that one. So if you guys have any questions, go ahead and leave a comment and I'll get to you guys as soon as possible. Or you can also come by during our office hours, which is 8:30 to 9:15 a.m. We'll see you guys. Bye.